Hi students, in this video we are going to discuss about expression for kinetic energy, and also we called this concept as kinetic energy theorem. Okay, now first tell me what is kinetic energy. What is kinetic energy? It is the energy possessed by the body by virtue of its motion is called kinetic energy. It is the energy. It is the energy it is the energy possessed it is the energy possessed by the body by virtue of its motion is called kinetic energy. Once again I am repeating, my dear students. It is the energy possessed by the body by virtue of its motion is called kinetic energy, which is denoted by E, or which is denoted by kinetic energy is equal to E. Okay, therefore E is equal to 1 by 2 mv square. Okay, E is equal to 1 by 2 mv square or half mv square. Dear students, take a mass of a body. Now, the same mass of a body is now at a point initially A. I applied a force here. As a result, the body migrated or moved from point A to point B without change of its mass. During its journey, it took a time t, and it acquired a displacement s. During its journey, its acceleration is called a. That means its initial velocity is equal to u, final velocity is equal to v. That means its initial velocity is equal to u, its final velocity is equal to v. This is the diagram about kinetic energy theorem. That means let an object of mass m. Initially, its initial velocity is equal to u. But consider u is equal to 0. U is equal to 0 means its initial velocity is u is equal to 0. It is lying on a smooth surface. A constant force F acts on an object such that the acceleration produced in the body, which is A, let the body moves with a velocity v after a displacement s. Okay, I hope you understood this diagram. Now go for matter. Let an object of mass small m be at rest. Be at rest. Full stop. The initial velocity of body is u. Okay, since u is equal 0, now it is lying on a smooth surface. On a smooth surface. A constant force F acts on the object such that the acceleration produced in the body is A. Okay, the acceleration produced in the body is A. Let the body move with a velocity v. After displacement yes. Once again, I am repeating the content. Listen carefully. Let an object of mass small m be at rest. The initial velocity of the body is u. Since u is equal to 0, it is lying on a smooth surface. A constant force F acts on the object such that the acceleration produced in the body is A. Let the body move with a velocity v after displacement s. This is the basic information about the diagram. But from third equation of motion, v square minus u square is equal to 2as. From this one, we know that, consider this is equation number 1, but u is equal 0, that means initial velocity is equal to 0. Consider this is equation number 2. Now 2 in 1, what happened? V square minus 0 square is equal to AS. Okay, V square is equal to AS. Therefore, A is equal to V square by 2S. Equation number 3. Once again I am repeating, my dear students. From third equation of motion, we know how many equations of motion in our 9th class? 3. First equation of motion, V is equal to U plus AT. Second equation of motion, S is equal to UT plus half AT square. Third equation of motion, V square minus U square is equal to AS. Now, but the body initially is at rest. Therefore, U is equal to 0. From third, once again I am repeating, from third equation of motion, V square minus U square is equal to 2S. Consider equation number 1. But U is equal to 0. Consider equation number 2. 2 in 1. That means V square minus 0 square is equal to 2AS. Therefore, V square is equal to 2AS. Therefore, A is equal to V square by 2S. Equation number 3. But the work done by the force in displacing the object is given by what is the formula? Work is equal to force into displacement. Consider it is equation number 4. But from Newton's second law, force is equal to ma. Consider it is equation number 5. This is from Newton's second law. Okay, now equation 5 in 4. What happened? W is equal to, what is F? ma into S, as usually we wrote here. Consider this is equation number 6. But A is equal to V square by 2S. Which equation this is? This is equation number 3. Okay, now 3 in 6. Therefore, we get W is equal to M A S in this one. M into what is A? V square by 2S into S. Please observe carefully. S and S going to be cancelled. that is equal to m v square by 2. Therefore, W is equal to 1 by 2 m v square. Okay? This is the required equation. That means this work done, this work done is stored. This work done is stored as kinetic energy. Stored as kinetic energy. The kinetic energy of the object is given by what is the formula? E is equal to 1 by 2 m v square. Therefore, the kinetic energy is equal to 1 by 2 mv square. This is the required equation, or energy is equal to 1 by 2 mv square. This is the required equation. I think you understood. What we understood from this one? The kinetic energy of a body is directly proportional to its mass and square of its velocity. Okay, that means as mass m and velocity square are always positive. Therefore, kinetic energy is always positive. Dear students, once again I am repeating this point. Please observe carefully. The kinetic energy of a body is directly proportional to its mass and square of its velocity. As mass m and velocity square are always positive, kinetic energy is always positive. We have to note that point. If suppose, if non-zero, initial velocity, non-zero initial velocity u, comma, the change in kinetic energy, the change in kinetic energy is equal to the work done that means take a body, we applied a force, initially its initial velocity u not equal to 0, that means it is already in slow motion, its mass is m. Now it acquired a velocity v. Now by applying a force, it acquired an acceleration a and its displacement s. It took a time t. In this case, the work done is equal to change of kinetic energy. We can call as delta Ke, where delta indicates small change. Small change means final kinetic energy minus initial kinetic energy. The difference is very small. That indicate delta. That is equal to 1 by 2 m v square minus 1 by 2 m u square. Once again, cadets, I am repeating. If non-zero initial velocity u, okay, the change in kinetic energy is equal to the work done. That means if we applied a force on a mass of a body, since we know that mass cannot be changed and initial velocity not equal to 0 and the body acquire a velocity v, which is also not equal to 0, we know. The body acquire an acceleration a and a displacement s, and it took a time t. In this case, the work done is equal delta Ke, that is equal 1 by 2 mv square minus 1 by 2 mu square. That means W is equal kinetic energy is equal, how we can write this? 1 by 2 m into v square minus u square. Okay, that means kinetic energy or change in kinetic energy, we write it as 1 by 2 mv square minus 1 by 2 m u square. This is also important point, we have to note it down. Dear students, I hope you understood this video. Thank you very much for watching this video.